Section 40 of Dr. Hackensaw's Secrets. Dr. Hackensaw's Secrets by Clement Fezandié. A Journey to the Center of the Earth, Part 1. Chapter 1. "Pep!" cried Dr. Hackensaw. "Do you want to take a trip with me?" "Sure, Pop," answered Miss Pepita Perkins gaily. "Where to?" "To the South Pole first, and from there possibly on to the center of the Earth." "What?" "Yes, Pep. I have decided to penetrate nature's greatest mystery and discover what lies at the center of our Earth. Up to date, nobody has the faintest idea of what is to be found there. For many years, the center of the Earth was supposed to be a liquid mass of white-hot molten matter on the top of which floated the cooled upper crust, about 100 miles in thickness. This belief was strengthened by the fact that in our minds the temperature increases slowly as the depth increases. It would follow that the center must be a white-hot mass. The existence of volcanoes would lend support to the belief. But of late years this view has been gradually abandoned. If the center of the Earth were a liquid sea of fire, this sea would be attracted by the sun and the moon, and our volcanoes would have daily high tides and low tides, the same as our oceans of water. Other circumstances, too, lead to the belief that our Earth is not fluid at the center, but is as rigid as steel. However, nothing really definite was known until I, a few years ago, set about exploring the nature of the center of the Earth by means of radio waves. Radio waves? What do you mean? I mean to say that radio waves in their passage through a medium are modified to a certain extent by the medium through which they are passing. I have accordingly spent a great deal of time in studying just what modifications are produced by passing these waves through different thicknesses of rock, sand, clay, gravel, and various metallic ores. Of course, I was obliged to use directed waves, for if the wave passed around the obstacle instead of through it, it would tell me nothing. After I had carefully tabulated the results of my experiment, I sent out several radio expeditions to test conditions at the center of the Earth. These expeditions were in pairs. Each pair was at opposite poles or points on the Earth's surface, thence to send and receive radio waves of prearranged strengths and frequencies, directed right through the center of the Earth. The vessels carrying the radio apparatus were, of course, timed to be at the same moment at opposite points. Following the same great circle of the Earth in the same direction, they were always opposite each other, and could arrange to stop every 100 miles on their course and exchange new waves. By comparing the result from all these expeditions and eliminating all the differences, I could tell just what resistance was offered by the central portion of the Earth, and could thus form some idea as to whether it were a mass of molten matter or solid rock. This was supplemented by the work of some other expeditions, which instead of following a great circle followed small circles of latitude or longitude. In this case, the radio waves exchanged did not pass through the center of the Earth, but through the chord of a sliced-off portion in this diagram. Dr. Hackensaw here showed Pep a simple sketch of a section of the Earth. This work served to control the other observations, because in this case the wave did not pass through the center of the Earth. "Well, did you find what the Earth is made of?" asked Pep. Dr. Hackensaw shook his head. "The results are most puzzling, and I don't dare to publish them. They are so wild, and so much at variance with the current scientific theories. Consequently, I am determined to make an attempt to penetrate the center of the Earth, in order to verify or disprove my theories." "Gee," cried Pep, "that's some job you're undertaking. How are you going to dig your way down?" "I'm going to make use of atomic energy to dig the tunnel. You were with me when we watched the blowing up of the rock in Central Park, so you have some faint idea of what my atomic force can do. Well, I have invented a digging machine for digging deep shafts into the Earth, by means of this same energy." "I understand," said Pep. "But what's your idea in starting from the South Pole? Why not start from here?" "There are several reasons," replied the doctor. "In the first place, we should be tormented here by reporters and curiosity seekers. But my main reason is that, as the Earth is flattened at the poles, I shall save several miles of digging. Besides, I have just received word from the agent of my colony at the South Pole that he has now discovered a pit, or extinct crater that seems to be about 5 miles deep. Of course, 5 miles is very little on a total of 4,000 miles. Yet every little bit helps. But I am wasting time. Now that you know my plans, are you still willing to come along with me? Sure, Pop. I wouldn't miss it for a circus. Chapter 2. Here we are, exactly at the South Pole, Pep. And I bet you can't tell me in what direction we are flying. I bet I can. We're going due south. We haven't changed our direction. Dr. Hackensaw's eyes twinkled. You're wrong, Pep, said he. We're going due north. A person standing exactly at the South Pole can travel neither east nor west nor south. No matter in what direction he goes, he will be traveling due north. Similarly, to a person at the North Pole, all directions are due south. How is it that the compass isn't vertical here? Asked Pep. For the reason that the magnetic poles do not coincide with the poles of the Earth. Scientists are not yet agreed as to the cause of the Earth's magnetism, but it is believed to be due to electric currents that circulate around the surface of the Earth. It is not the Earth itself that attracts the compass, but the needle is acted on by these electric currents, and the currents are probably caused by the heat of the sun striking the Earth further and further to the west, as the sun apparently travels from east to west between sunrise and sunset. Here we are over my polar plantations that we visited once before. We shall not stop there today, but push right on for our goal, 50 miles further on. A few minutes brought the airplane to the spot, and the doctor and Pep alighted to confer with the doctor's agent, who had received orders to make all necessary preparations for starting work. By means of atomic energy, the snow and ice had been cleared away from most of the territory, with the exception of a collection of ice huts, which had previously been constructed by a very rapid method, having been made in a mold into which water had been poured and allowed to freeze. On upending the mold, the ice house slid out all ready for occupation. Mr. Sam, the agent, was delighted to see our travellers, and was especially interested in the doctor's electric aeroplane, the Dart. Where are the storage batteries? Queried Mr. Sam. There are no batteries, replied the doctor. I thought you said it was electrical. So it is, at least as much as storage batteries are electrical. A storage battery, of course, does not really store up electricity. It stores up chemical energy. Electricity is no more stored than it would be if we used the current to decompose water into hydrogen and oxygen, and then burned the gases and used the heat to run a dynamo and produce new electricity. In my airplane, it is atomic energy that is converted into electricity and runs the propellers. But we have no time to lose. Have you cleared out the bottom of the pit so we can begin our digging? Everything is ready for the start, said Mr. Sam. The pit is cleared out and the diamond drill has started. How does the diamond drill work? Asked the doctor. First rate, but it seems a pity to use those immense diamonds worth hundreds of thousands of dollars for the purpose of digging through rocks. Don't let that worry you, replied the doctor. I have found the means of producing large diamonds as cheaply as we can produce graphite. They are nothing but charcoal in another form, but their hardness makes them ideal for drilling work like this. If you'll just jump aboard the Dart, I'll take you down to the bottom of the pit so we can see how things are progressing. By the way, observed Mr. Sam, I am convinced that this pit must continue much further down. It seemed to be blocked up by a fault in the geological strata. This fault completely closes the bottom of the pit. But unless I am very much mistaken, when we dig a little deeper we shall find that the pit extends considerably further. In that case, remarked Dr. Hackensaw, there would be danger of the drilling tool and the workmen dropping right through into the hole below. I have guarded against that, explained Mr. Sam modestly. I have placed the workmen and the drill on a movable platform, and this platform is supported by chains securely fastened above. In fact, I have gone even further. I have enclosed the entire platform hermetically in a kind of large metal bell, closed at the bottom, the drill projecting through a stuffing box. What was your object in doing that? I had two reasons. In the first place, I wished to protect the workmen in case carbon monoxide or other poisonous gases should be present, and secondly, to avoid danger in case there should be a partial vacuum below that might suck down the men. You acted very wisely, said Dr. Hackensaw, who made a careful examination of the machinery. All right, said he. Everything seems okay, Mr. Sam, and you can start the drill going again. Mr. Sam pressed a switch, and the enormous diamond-pointed auger began cutting its way down through the hard rock as though it had been cheese. Chapter 3. Did you say this pit was 5 miles deep? Asked Dr. Hackensaw of his agent. Yes, replied Mr. Sam. That is the approximate depth. I didn't measure it exactly. I merely let a bomb fall into the pit from above, and I found that 60 seconds elapsed from the time the bomb left my hand to the time I heard the explosion. Hence, this pit must be nearly 5 miles deep. "How do you figure that?" asked Pep. Dr. Hackensaw explained. "You see, Pep," said he, "a body near the surface of the earth falls 16 feet the first second, 48 feet the second, 18 feet the third, and so on. As a physicist would say, the total distance fallen equals g times t squared divided by 2, in which g stands for the attraction of gravitation. In other words, the acceleration of 32 feet per second of a body near the Earth's surface. If the distance fallen were great, this figure would be too large, as the portion of the Earth passed through would pull the body backwards. It is sufficiently accurate, however, for the present purpose. To fall 5 miles, therefore, the body would take 16 t squared seconds. As a mile contains 5,280 feet, t squared equals 5 times 5,280 divided by 16, or 1,650 seconds. Therefore, the time is the square root of 1650, or a trifle over 40 seconds for the bomb to fall the 5 miles. "But," objected Pep, "he said it took the bomb 60 seconds to fall." "No, he said that it was 60 seconds before he heard the noise of the explosion. It takes sound a trifle over 4 seconds to travel a mile. So it would take 20 seconds for the sound of the explosion to travel the 5 miles. In other words, it took the sound 1/3 as long to travel back as it took the stone to fall. Had the pit been a little deeper, the stone would have traveled faster than the sound. But, as you see, 40 seconds to fall and 20 seconds for the sound to travel back show that the pit is just 5 miles deep. This will save us quite a little digging." "How long will it take for the drill to go a mile?" asked Pep. "I hope we won't have to wait an age here." "We'd have to wait pretty long if I had only the diamond drill to depend on. But I am using that just to get a start. Tomorrow I shall take out the diamond drill and put my atomic drill in its place." "Will the atomic drill go faster?" "A great deal faster. In fact, there is no comparison between the two. Atomic energy is a wonderful power, and I have fortunately succeeded in harnessing it up in such a way as to avoid all danger." "How does the atomic drill work?" "Well, it's not exactly a drill. I call it that merely for convenience. It is in reality more in the nature of a torch. There is the machine ready to be put in its place. To understand its working, you need only think of a gasoline torch melting a hole through the ice on a skating pond. Swing the torch around in a circle, and it will soon dig deep into the ice. My atomic energy torch acts in much the same way. Instead of gasoline, my fuel, if I may call it so, consists of finely pulverized sand, which I place in the reservoir of the drill or torch. By means of the ignition device, as I call it, that you see near the torch, I am enabled to obtain undreamt of voltage, and am thus enabled to start the disintegration of this dust. As the pulverized sand disintegrates, the liberated energy not only accomplishes work, but causes the disintegration of more of the sand. By feeding the dust slowly to the tip of the torch, or the burner as I call it, the disintegration will continue as long as any sand is left in the reservoir. The heat generated in the process is enormous and melts the rocks and earth as if they were so much light snow." "How is it that the rocks and the earth do not disintegrate?" asked Pep. "For 2 reasons. First, they are not so finely pulverized as the dust I use, and secondly, I am careful not to bring my torch too near. I keep it far enough away so it will melt the rocks without getting them to disintegrate, if I may use the expression." "How do you get rid of the molten rocks?" "The molten material is carried up by endless chains of buckets. The work will be done automatically, so there will be no risk of the workmen being injured." "How is it that your torch and your buckets do not melt?" "They are kept cool by electricity. I haven't time to explain the process now, but it has long been known that the electric current can be used for cooling as well as heating. Electricity is a wonderful power. There is almost nothing that it is unable to accomplish if properly directed. But enough of this lecture. The men are stopping the diamond drill now, and will soon disconnect it and set up the atomic torch in its place. Then you will see the sparks fly. I have arranged an X-ray machine so that we can witness the effect of the atomic torch as it digs its way downward through the rocks. Several hours were required to make the change, but Dr. Hackensaw and Pep waited to see the torch well set up in place and started in operation. It was interesting to see the rapidity with which the rock melted under the impact of the white-hot ionized particles, and the stream of fluid lava was blown into buckets by a stream of helium gas. Luckily, it was not necessary to carry the molten lava to the surface of the earth. There was a deep side channel a short distance up the pit, and into this the molten rock was poured. The buckets, the drill, and the closed chamber in which the operator stood were all protected from the heat by electrical refrigerating devices. A supply of air in the workroom was furnished from tanks, as the noxious gases generated by the heat would have been irrespirable. A microphone of special construction with a series of amplifying devices carried to the doctor and his assistants the faintest sounds. It was provided with a sort of tuning device which enabled them to listen at will either to the sound of the revolving torch, to that of the seething lava, or cutting both of these out, it enabled them to listen to whatever other fainter sounds there might be. This precaution was necessary, as the doctor had no idea how deep the fault might extend, and to cut completely through into the pit below would have been exceedingly dangerous. That a cavity existed below was certain. There was a hollow, cavernous sound produced by the reverberations of the rock through which they were cutting, sounds analogous to those of a drum when rubbed. Down, deeper down went the torch into the earth's entrails, until finally the reverberations became so great that Dr. Hackensaw gave orders to halt the atomic energy torch. "It sounds as if there couldn't be more than a foot of solid rock below," said he, "and then we shall strike the open pit again. We'd better install the diamond drill once more, or rather a 2-inch drill, so as to cut a small hole into the pit." No sooner said than the work started. The torch was disconnected, and after cooling the rock, the small diamond drill began boring down through the last few inches of the fault. The work progressed rapidly when suddenly there was a tremendous suction of air, and with a whistling sound the drill was sucked right into the opening it was making, and was only held back by the chuck. "Good gracious!" cried Dr. Hackensaw. "There's a partial vacuum down below there. Before we can do anything more, we must make an airlock outside of this working chamber. Then, by exhausting the air in the airlock, it will be possible to draw out the drill and drop a bomb down into the pit to ascertain its depth." This work occupied several days, but finally all was in readiness. The drill was withdrawn, and at a sign from the doctor, Pep touched a button that allowed a small bomb to drop into the hole. They all waited anxiously. 1 whole minute passed, then another, then a third, and the minutes slowly succeeded each other, until finally, just as the doctor was about to remark that the bomb must have failed to ignite, the sound of the explosion was plainly heard through the loud talker. "Good gracious!" exclaimed the doctor again. "Allowing for the time it took that sound to travel back to us, it is certain that the pit below us is over 100 miles deep." To be continued. End of A Journey to the Center of the Earth, Part 1. End of Section 40. Section 41 of Dr. Hackensaw's Secrets. Dr. Hackensaw's Secrets by Clement Fezandié. A Journey to the Center of the Earth, Part 2. Chapter 4. "Jerusalem!" exclaimed Dr. Hackensaw. "This 100-mile pit will save us a lot of digging, but it forces us to change our plans immediately. Evidently, a partial vacuum exists in this pit, and our first step must be to ascertain exactly what degree of vacuum exists. Luckily, this will be easy, as I have a couple of special Geissler tubes with me, so constructed that air may be admitted or pumped out at will. One of these tubes I shall open and let down into the pit. The rarefied atmosphere of the pit and that in the tube will soon equalize. By passing an electric current through the tube and comparing the fluorescence with that of the second tube, into which I can admit more or less air, until the 2 tubes emit an equal amount of light, I shall know that the vacuum in the pit is exactly equal to that in the second tube." The experiment was tried, but when the results became known, Dr. Hackensaw shook his head. "The air density in the pit is really very slight," he exclaimed. "In one way, of course, this is an advantage, for it will relieve us of the danger of encountering an enormous air pressure down below. But on the other hand, it will make the start difficult." "Couldn't you let in more air?" asked Pep. "Certainly, and I should unhesitatingly do so if I were convinced that the pit were only 100 miles deep. I believe it to be much deeper, however. But you said the bomb exploded 100 miles below the surface. So it did, but it may have struck the side of the pit, or it may even have been set off by the compression of the air in front of it. However, to save time, we'll do a little exploring. The electric airplane, the Dart, is provisioned for 6 months, and has an oxygen supply sufficient for 3 months. Accordingly, if we are prudent, we will have little to fear. What I shall do will be to provide some 25 or more miles of light but strong chain, fasten them to the rear of the airplane, and let the car slowly down so we can examine the pit a little. To aid in this work, I shall have some suits made in the style of light diving suits. These will be provided with suction boots made on the principle of a fly's feet, the suction enabling me to walk down the sides of the pit without danger of falling, just as a fly walks head downwards on a ceiling. "Gee!" cried Pep. "Make a pair of those boots for me, too. But won't it be tiresome to hold our bodies stiff?" "No, I shall have a metal framework made to wear under our clothing. The whole weight of our bodies will thus be borne by the metal frame, and not by our muscles. Of course, we shall not be able to use these suction boots so long as the air in the pit is so rarefied. It requires normal atmospheric pressure to make sufficient suction. We can only use the boots in case the pressure is greater down below, or in case I let air from above into the pit." Chapter 5. Several weeks were required for the necessary preparations, and Pep was becoming very impatient, when one fine day Dr. Hackensaw called to her, "Pack your bag at once, Pep. We start at noon." An hour later, the two, accompanied by Miggs, who was to act as pilot for the airplane, had descended into the closed chamber, ready for the start down into the apparently bottomless pit. At sight of the Dart, however, both Miggs and Pep uttered a cry, for the compact spindle-shaped airplane they were familiar with now resembled one of the giant squids or octopuses familiar to all movie fans. Fastened to the rear of the airplane were several long tentacles or arms, resembling huge metal springs set in a circle. It was, in fact, almost an exact imitation of an octopus. Below was a second set resembling the first. "What in the world are those arms for?" asked Pep in surprise. "Those are to serve as brakes," explained Dr. Hackensaw. "As there is practically no air in this portion of the pit, our car would fall down at frightful speed if allowed to drop in." "But I thought the car was to be held back by a chain." "So it is for a short distance, but we cannot place much dependence on the chain, and must soon cast loose from it anyway. Now, I have ascertained that the pit is really a narrow well in the solid rock. As we descend, I shall force these metal arms against the sides of the well, and so be able to check our descent, or stop completely, at will. An electric equalizer will automatically keep the pressure equal in each arm, so that our descent will be steady and uniform. Electric refrigerating devices will keep the ends of the arms from melting through the heat produced by friction against the rock. Should one of the arms become worn or injured, a new arm from below will automatically replace it. I can set the device so that the springs will press against the walls with any degree of pressure I desire. But we can't stand here talking. We must get inside the car, for we have a long way to travel, and I don't dare to get up too much speed. This will not be a joyride by explorers. I have an excellent searchlight on the car, which will reveal our path for a mile or more ahead of us, but it would not pay to be imprudent." "One moment, Doctor," objected Miggs. "You say these brakes are needed to hold us back. Couldn't you reverse the propeller and hold the car back that way?" "Certainly I could if there were normal air at atmospheric pressure in the pit, but there is so little air here that the propeller would have nothing to work against. You cannot push the car backwards unless you've got air or something else to push against." "All right," said Miggs. "I understand that, and I see that without the brakes we would just drop down into the pit. With the help of the brakes we shall get down all right. But if we can't use the propeller, how in the world are we ever going to get up again?" Chapter 6. Dr. Hackensaw smiled at the boy's question. "Don't be afraid, Miggs," said he. "I am not any more anxious than you are to be left down at the bottom of this 100-mile hole, without any means of climbing up again. You know the old Latin proverb, facilis descensus averni. It means that it's easy enough to go down, but not so easy to come up. I didn't find it so easy as all that to go down, but in our case it won't be very difficult to come up again." "How will you manage it?" "Simple enough. The cause of our trouble is that there is almost no air in this pit. The remedy is self-evident. We must let some air in from above, when we wish to return. I have arranged with Mr. Sam, the agent, to let air in by degrees on our return trip. If possible, I shall signal to him by radio just when to send in the air. In case anything goes wrong with our radio apparatus, however, he is to let in air enough so that our car shall always be in an atmosphere of about 15 pounds to the square inch when we return. In such an atmosphere, our propeller can easily raise the car, and we can fly back without trouble. If he let in too much air, the pressure down below here would be too great and might cause trouble. How can Mr. Sam know where the car is and what pressure it exerts? The car itself is a large permanent magnet, and by means of an ingenious amplifying device, its distance from the surface of the earth is indicated on an extra-sensitive galvanometer in Mr. Sam's office. But to leave theory and come down to practical matters, there are only 3 of us in the car, so we must take turns as pilots. Each of us will take a trick of 2 hours at the controls, and then have 4 hours rest. There is very little for the pilot to do, as everything is arranged to work automatically as much as possible. Yet it is only prudent to have someone constantly on guard. Our searchlight shows the way for more than a mile ahead. There is a smoked glass window for the pilot to look through, without being blinded by the rapid flashing by of the illuminated walls. My dependence, however, is not on the pilot. I have other devices to ensure our safety. In front of the car is an electric gong, which will ring continuously during our descent. This will be a great protection. "What in the world will be the use of a gong?" asked Miggs, puzzled. "You surely don't expect to meet another car coming up." "No, but I do fear to find some obstruction in the path, or to find a sudden turn in the pit, or even to find the pit completely closed." "But what use will the gong be?" "By means of a parabolic reflector, I shoot the sound straight in front of the car. If there is no obstruction in front of us, there will be no echo. If, however, there is anything in the way, some of the sound waves will be reflected back to us and warn us of our danger. Not only will these waves sound an alarm, but they will automatically work a relay that will work the brakes and check the speed of the car. To make assurance doubly sure, I also shoot forth an ultraviolet ray in front of the car which acts in the same manner. When this ray strikes an obstruction, it is reflected back and acts on a photoelectric cell in the car, also sounding an alarm and putting on the brakes. This device is more delicate than the other, but it has the advantage of speed, for the light waves travel much faster than the sound waves. But we're wasting time. Everything is ready now for the start. I'll take the first trick at the wheel so you can watch me and see how things work. As you would feel a peculiar sensation when we acquire speed, a sensation similar to that experienced on a rapidly descending elevator, you will find it advisable to lie down on the adjustable couches. These couches are provided with a universal joint, so they can be adjusted to any position desired. As you see, there is a similar one provided for the pilot. Now then, are you all ready? Yes? Then I press the button and down we go. Chapter 7. The car trembled for an instant, and then slowly began its descent into the bottomless pit, the chain that held it gradually unwinding as the car descended. By slow degrees the doctor increased the speed. The brakes had already been tested out on several previous short trial trips, but so much depended upon their proper working that the doctor now put them to a series of more strenuous tests. He would allow the car to drop suddenly a short distance, and then apply the brakes with a jerk. He was overjoyed to find that they checked the descent of the car at once, and without showing any signs of strain. The passenger suffered more than the brakes, and Pep, off her guard, was even once thrown off her berth to the ground. But she picked herself up, laughing, and accused the doctor of doing it on purpose. Satisfied that everything was in perfect order, Dr. Hackensaw gradually increased speed, and soon the car, or the squid, as Miggs persisted in calling it, was falling downward at a uniform rate of 40 miles an hour. At the end of a couple hours, the instruments indicated that a depth of 80 miles had been reached, and that the vacuum in the pit was not quite so great as at the start. "You've got to look out now," said Miggs, "as the pit is only 100 miles deep. We'll strike the bottom in another half-hour." "No danger of that," replied the doctor. "The pit must extend several hundred miles further." "What makes you think that? Didn't you tell us that the bomb which dropped down exploded 100 miles below the surface?" "So it did, but the explosion was in all probability caused by the speed of its fall. It didn't go down quietly the way we did, at 40 miles an hour, but fell at a constantly increasing speed. The compression of the air in front probably sufficed to force the back of the detonator that causes the explosion of the bomb." "But what makes you think we are not near the bottom of the pit?" "Because the air, which is getting slightly denser, doesn't seem to be reflected back to us. If the bottom of the pit were a few miles away, We ought to feel a stronger back pressure or breeze than the instruments show. I am so sure of the fact that the bottom is a long way off that I am going to increase our speed to 100 miles per hour. All right, but go slow, said Pep, who didn't want another fall. The speed was gradually increased, and now our friends found that their bodies, as before, seemed a trifle lighter as the velocity increased. An acceleration of 32 feet per second would have caused them to lose all their weight and float in the air. Of course, their speed only increased a very small fraction of this, so the loss in weight, while perceptible, was perceived more as an uncomfortable feeling than as a sensation of lightness. Now, Pep, said Dr. Hackensaw, as we have a long and probably monotonous journey before us, suppose you hook up the radio set and see if you can catch some good music from one of the broadcast stations. Chapter 8. The start had been made at 8 o'clock in the morning in order to give a long day for the exploration, though of course there was no distinction between day and night in the pit, and the party could turn the electric lights in the car on and off at will. The music broke up the monotony of the trip, and cards and checkers and letter writing, the messages to be sent by radio, helped to pass the time. Pep had resolved to send to her special friends missives from the center of the earth if she should ever reach the spot. As time passed, the three friends found that their weight was becoming perceptibly lighter. Pep, who weighed 120 pounds normally, found when she suspended herself from a spring scale in the car that she now weighed only 100 pounds, and her lightness increased every hour. Another sign that they were approaching the center of the earth was that the tension of the brakes against the walls of the pit, as indicated by a gauge in the car, became gradually less. Miggs inquired the cause of this from the doctor. You see, Miggs, explained Dr. Hackensaw, I have set the speed of the car to remain automatically 100 miles per hour, this being the highest speed at which it is prudent to travel. When we go faster than this, the brakes automatically press tighter against the walls of the pit, and so retard our speed. On the other hand, when we go less than 100 miles per hour, the brakes automatically relax a trifle, allowing us to fall faster. But why should we slow up as we near the center of the earth? I always thought the velocity would keep on increasing until the center of the earth was reached, and only begin decreasing after we had passed the center. So it would, Miggs, if our car were falling freely in a tube deprived of air. The acceleration of speed would each second become smaller and smaller, but would be added to the previous speed, so that when we reach the center we should be traveling at a terrific rate. But as the brakes keep the car at a uniform speed of 100 miles per hour, and the pull of gravitation becomes smaller each second, the car would gradually slow up and stop unless I eased up on the brakes. Another thing that retards us is that the air is getting denser. It is now 6 o'clock, dinner time by the way, and we have been falling for 10 hours. Of course, we went slowly at the start, but we have fallen nearly 900 miles now. If you look at the air gauge, you will see that the air in the pit is perceptibly denser. Not yet the normal atmospheric pressure of 15 pounds to the square inch, but approaching it. Miggs looked at the simple gauge that indicated this pressure. It was nothing but a diaphragm. A valve allowed air from the pit to enter one side of the diaphragm, and air from the car was admitted by another valve to the other side. A rod fastened to the diaphragm was thus pushed forward or back, indicating the pressure by pushing a needle pivoted on a dial. The trio sat down to a hearty meal, taking short tricks of 5 minutes each on the pilot seat, so that all might enjoy the meal together. Care had to be taken in moving around, for their bodies had lost so much weight that a too brisk movement would cause them to jump high in the air. In fact, once poor Pep accidentally jumped so high that she kicked Dr. Hackensaw on the head, knocking him down. Luckily, his light weight prevented him from hurting himself. If we were falling freely, and there was a perfect vacuum in the tube, explained the doctor, we should have had no weight at all during the entire trip, for we should ourselves have been attracted no faster than the car, even if we were in mid-air. As things are, however, we shall not lose our weight completely unless we stop at the center of the earth. At present, our weight is governed by 3 factors. 1. The speed of the car. 2. The acceleration produced by gravitation at the spot we have reached. And 3. The density of the air in the pit. How does the density of the air in the pit affect our weight? Inquired Miggs. It retards the car, but does not retard our bodies. Hence it increases our weight on the spring scale, or at least it would increase it if the car were falling freely in the pit. After dinner, Dr. Hackensaw examined the instruments again, and then started to make some calculations. The result seemed to puzzle him. Thinking he had made some error, he started all over again, but seemingly with no better result. "What's the matter?" asked Pep. "I don't know, but something's wrong. We are now 1,200 miles below the surface of the earth, but our weights are much less than they ought to be at this spot. Something is wrong somewhere, unless—" He hesitated an instant, then a gleam of excitement came into his eyes. "I have it!" he cried. "I understand everything now. I understand why our weight is almost nothing at present. I understand, too, what puzzled me so much in the radio observations we made before starting, by sending directed waves through the center of the earth from surface to surface. But if my hypothesis is correct, the center of the earth must be an even more marvelous place than anyone had ever suspected it to be." End of section 41. Section 42 of Dr. Hackensaw's Secrets. Dr. Hackensaw's Secrets by Clement Fezandié. A Journey to the Center of the Earth, Part 3. Chapter 9. Down, down went the car on its journey toward the center of the earth. And now the automatic brakes no longer pressed against the sides of the well to check the speed of their descent. Instead of this, the doctor had started the propeller working backwards, for the air in the pit had now reached more than normal density, and the propeller was easily able to check any increase in speed, or even to stop the car completely. Dr. Hackensaw assured himself by a test that such was the fact, and was overjoyed to find that the propeller could now even pull the car upwards. Consequently, the tentacular brakes became useless, and were withdrawn until they should be needed again. Miggs was very much interested in the engine, which was electrical in the sense that it made use of atomic energy as a motor power. The mechanism was as simple as it was efficient. The power was obtained by disintegrating molecules of sand. The sand was first pulverized to an incredible fineness. As this fine dust hung suspended in the air, a sticky thread, whose composition Dr. Hackensaw kept a profound secret, was drawn rapidly through a room filled with it, and passed over heating surfaces which dried it, and the dried thread was wound on spools like ordinary sewing cotton. Dr. Hackensaw had made all these preparations in New York, and had brought with him a number of spools of this prepared thread, which was to serve as motive power as well as for producing heat, cold, light, etc. The disintegration of the dust particles imprisoned in the thread was started by an electric current at an undreamt-of potential. Once started, the disintegration proceeded automatically from one dust particle to the next, the thread being fed forward as fast as consumed. In principle, it was like a gas jet, which requires to be lighted at the start, but once started, the flame keeps igniting the new gas as it streams forth from the burner. The doctor had started the disintegration process before leaving the surface of the earth, where he had facilities for producing the high potential required. This greatly simplified the equipment in the car, which consisted merely of the connections required for turning the propeller. Dr. Hackensaw kept an eye on the odometer, and also on a weight suspended to the spring scale. Finally he uttered an ejaculation and cried out, "Pep, do you want to see what it feels like to have no weight at all?" "Sure, Pop," replied the young girl, and Miggs echoed her wish. "Very well. Then I shall stop the car here, for unless I am greatly mistaken, we have reached a spot where we shall have no weight at all." "How can that be?" asked Pep. "The odometer says we have only gone 1,500 miles, and you told me that the center of the earth was 4,000 miles from the surface. We can't be anywhere near it yet." "True," assented Dr. Hackensaw. "That's a puzzle, the solution of which you will soon learn for yourself. In the meantime, we shall make a short halt for amusement." The car, which had been descending at a uniform speed of 100 miles per hour, was now gradually slowed up until it came to a complete stop. Long before this point had been reached, the three friends had found their weight gradually diminishing, and they were obliged to hold on to specially prepared handles arranged in the car, in order that a slight movement might not send them spinning in all directions. The lightness was especially emphasized by the rapidity of their motions. Their muscular force being unimpaired, and their arms and legs having lost all weight, any exertion would move an arm or leg 16 times as fast as when opposed by gravity on the surface of the earth. The result was comical in the extreme. As soon as the car stopped, Miggs, anxious to convince himself that he had indeed lost all weight, made a jump for the ceiling. The result was a complete surprise to him. Instead of going straight up, he began turning a rapid series of somersaults in the air, and was shot up against the ceiling with a bump, and then bounced up and down again until Pep, clinging with one hand to a couch securely fastened to the frame of the car, as was every other object in it, caught him with the other hand. A book that Pep had been reading and had carelessly laid down on the table was started off by the slight shock when the car stopped. or perhaps by a slight breeze made by the motions of the passengers, and ascended slowly to the ceiling. To catch the book, Pep swam slowly upward through the air. Although she tried to make her movements very deliberate, her arms worked faster than if she were swimming in water. After she caught the book, she thoughtlessly put out her hand to keep her head from striking the top of the car. But she pushed too hard, and she too went somersaulting around the room, though more slowly. Her push being diagonal, she found that instead of going straight up and down, she bounced from the ceiling to the wall on one side, then to the floor, then to the opposite wall, and then to the ceiling again, traveling around in a sort of circle, and all the while spinning somersaults in a graceful but most unladylike manner. Dr. Hackensaw, laughing as he watched her, in an unguarded moment released his hold, and he too performed a series of grotesque acrobatic contortions as he circled through the air. Finally, Pep caught the doctor on the fly, and holding him by one leg, finally managed to catch hold of a couch, and so checked their breathless flight. "It's lucky we didn't break any of the glass instruments in our gymnastics," panted Dr. Hackensaw. "Why, how could we break them?" asked Miggs. "As we have no weight, we couldn't break them no matter how hard we hit them. It would be like trying to break them by throwing a feather at them." "Don't you believe it, Miggs," replied Dr. Hackensaw. "If you had hit one of those instruments, it would have smashed into little pieces. Momentum is a question of mass and velocity. A feather has very little weight and very little mass, and hence cannot acquire much momentum. But you, although you have no weight, have just as much mass as you had on the surface of the earth, and I tremble to think what would have happened if one of us had hit those instruments. I see you're rubbing your head, so you have had practical proof that even though you have no weight, you can give and receive hard bumps when you butt into an object." Chapter 10. "Ladies and gentlemen," cried Pep, "just keep your eyes on me for a minute, and I'll give you a sample of the latest dance, the aerial whirl." With these words, she swam slowly and carefully to a point in the center of the car, midway between floor and ceiling, and, after having carefully checked her impetus, she performed a series of the most graceful evolutions, slowly gyrating as her hands and feet went through the motions of an oriental dance. A moment she would be upright, a moment later she would be horizontal, then head downwards, but her feet and hands kept going as she imitated the poses of the ancient Egyptian and other oriental dancers, while she accompanied herself with a song. Gradually her motions became more rapid, faster and faster she spun around, until she was whirling around with a terrific speed like a windmill. Finally she stopped, breathless, but even then the gyrations continued, until she checked them by motions in the opposite direction. "Gee, that was great!" she cried joyfully. "It's a dance of my own invention, but it beats anything I've ever seen." As soon as the dance ended, Dr. Hackensaw made a few observations to convince himself that the car was now really at the center of attraction. Then he started the propeller going again, and continued the journey. No longer were the brakes needed. On the contrary, the propeller had to do all the work, for the car was no longer falling, and as mile succeeded mile, the propeller had to work faster to keep the speed unchecked, for the car was now being pulled backwards by the attraction of gravitation. The weight of bodies was still so slight that Pep and Miggs amused themselves with all kinds of queer antics. Once Miggs knocked Pep down, and in retaliation she seized him by one foot, swung him around her head, and hurled him at the roof of the car. He bumped against the ceiling and bounced around the car several times before he could stop himself. Dr. Hackensaw then explained that if there were no air in the car, and the car were stationary at the center of the earth, no exertion made by a passenger suspended in mid-air would enable him to reach top, bottom, or sides of the car. He could spin around at will, but could not displace his center of gravity in any way, as there was nothing against which he could push. Action is impossible unless there is an equal reaction. "If Miggs were up in the air with you," explained the doctor, "you could push him, and the push would send him to one side of the car and you to the other. Otherwise, you would die of starvation even if food were plentiful in the cupboard here. You couldn't reach it. Of course, air in the car offers a certain amount of resistance, and so enables you to swim easily from one point to another, as the acquired speed keeps your velocity increasing until the resistance of the air equals the acceleration." "I bet I could reach the side of the car," said Miggs. "How would you do it?" "I'd take off my jacket and throw it in the direction opposite to the one I wanted to go. The jacket would reach one wall, and I would be pushed backward and reach the other." "Bravo, Miggs!" cried the doctor. "That's a very clever idea, and would certainly succeed. If your jacket weighs 5 pounds and you weigh 100 pounds, the jacket would travel 20 times as fast as you would, But you would eventually reach the other side, unless the resistance of the air stopped you. If it did, I'd shoot off my pants the same way, exclaimed Miggs, and at this heroic measure both the doctor and Pep laughed heartily. And now the weight of bodies in the car kept getting heavier and heavier. The speed of the car had been gradually increased until the speedometer indicated 100 miles per hour. The air pressure in the pit at the center of attraction had been over 50 pounds to the square, more than triple the normal atmospheric pressure. But now the air gauge showed that the pressure was diminishing again. Dr. Hackensaw called Pep's attention to this matter and showed her how it confirmed the indications of the spring balance. "Everything goes to show," said he, "that we reached the center of attraction when we were only 1,500 miles below the surface of the Earth. There bodies lost all their weight and the air was densest because under greater pressure. The air above and below were both pressing towards the center of attraction." "In that case," said Pep, "the Earth can only be 3,000 miles in diameter from pole to pole." "No, the Earth is 8,000 miles in diameter. There is no possible question about that. Men have circumnavigated the Earth, and scientists have accurately measured the length of a degree of longitude. Other observations confirm these results. There is no doubt of the accuracy of the figure 8,000 miles as the diameter of the Earth." "Then how do you explain that bodies 1,500 miles down had lost all weight?" "I see only one explanation. The center of the Earth must be hollow. The Earth must be a hollow sphere within a crust or shell 3,000 miles thick. This would explain everything, and tallies with the radio observations that I had made before starting. As I told you, I sent ships to circumnavigate the globe, one ship in each pair, following the other around on a great circle, always keeping exactly opposite to its twin. That is to say, 180 degrees from the companion ship. These ships sent directed radio waves straight through the center of the Earth to each other. The result of these observations, when summed up, convinced me that there must exist an enormous hollow at the center of the Earth, filled possibly with air or gas. I am now more than ever confirmed in this belief, but if the pit we are in extends to the center hollow, as it seems to, we shall in the course of a day or so know the truth." "But," objected Pep, "even if the Earth is hollow at the center, it seems to me that bodies ought to keep weighing more and more as we go down." "Not at all," replied the doctor. Then, with some difficulty, he took his notebook from his pocket and drew the following rough diagram. Here is the gist of the proof given by Sir Isaac Newton in his Principia, to show that a body situated at any point within a hollow sphere will not be attracted in any direction by the shell, or rather, that the opposing attractions will neutralize each other. Let C be the body inside the shallow sphere, and consider the piece of the shell A that attracts the body in one direction. There will be, opposed to this force, a pull from the portion B of the shell opposite to A. The attractions A and B are proportional to the areas A and B and inversely proportional to the squares of their distances from the object C. But the areas A and B are to each other as the squares of any homologous lines. Hence, they are to each other as the squares of their distances from C. Hence, the two opposite poles are exactly equal and neutralize each other. If my supposition is correct, and if the Earth is really a hollow shell, we shall find when we reach this hollow space that no matter what the position of the car in the central hollow, we shall have no weight. You will there be able to dance your aerial whirl as easily as you did now. But enough of this lecture. I wish now to send a radio message to Mr. Sam, telling him all that has happened to us so far. When I have finished, we can listen in and receive the latest broadcast news, and hear a little jazz music to liven us up. Chapter 11. "Pop," said Pep, after the radio concert was over, "I find now that I weigh only 5 pounds on the spring scales. Before we get any heavier, I want to do a little circus stunt with you and Miggs. Don't say no, because I may never get another chance." "What do you want to do?" "I want to do a little balancing act. I want to hold you and Miggs in one hand. Come, Miggs, there's a good boy. Let me lift you up. Now, just stand on my hand and hold on to me while I lift the doctor up. Then you're to grab him, stand him up on your right hand and balance him there. And then, when you're ready, you can let go of me and stand upright in my hand so that I'll be balancing the two of you at once. Gee, won't it be fun?" Dr. Hackensaw somewhat reluctantly consented to the experiment, and a moment later he was perched upright in Miggs's hand, while Miggs in turn stood on Pep's open palm. The young lady found she could easily balance them in this position, the two of them together weighing only about 10 pounds. Not satisfied, however, with this success, she decided to try to balance the two of them on her nose. Poor Dr. Hackensaw obediently allowed himself to be placed on the tip of Mr. Miggs's nose, while Pep stood Miggs on the end of her own, Pep's dainty nose, which flattened out somewhat under the 10-pound weight. Everything went on swimmingly for a minute or two, and then Pep tripped on the foot of the table that was fastened to the floor, and down fell the human tower in an inglorious heap. Fortunately, the travellers weighed so little that no one was seriously hurt. And so the time wore on, hour succeeding hour, each one bringing an increase of weight. Then suddenly the electric alarm bell rang. "Good gracious," cried the doctor, "there must be some obstruction in the path. Your capers, Pep, have made me neglect keeping as sharp a watch as prudence demanded." Long and earnestly the doctor peered forth down the shaft, but he was unable to see any obstruction, and yet the alarm kept on ringing. "I don't understand it," cried the doctor. "The selenium cell alarm should ring only if there is some obstruction in the path that reflects back the rays of our searchlight, yet the pit seems as open as ever. Perhaps there's a short circuit in the cell. Our gymnastics in the car may have shaken the wires around a little. I'll shut off the searchlight for a minute to see." Accordingly, the doctor switched off the light, but the alarm continued ringing just the same. Yet an examination of the cell showed no visible short circuit. "I don't see what the matter can be," he cried, "but I'll slow up a little, for it wouldn't do to have an incident down here, over 2,900 miles below the surface of the earth. Our friends would have some trouble in getting our bodies out." The necessary precautions taken, the journey continued at a slightly reduced speed, the doctor in the pilot box keeping a sharp watch ahead, with hand ready to switch off the propeller and the other to apply the tentacle-like brakes. But time passed, and yet no obstruction appeared, though the alarm rang louder and louder. Dr. Hackensaw, more and more puzzled, took a telescope from among the miscellaneous instruments in the cupboard, and gazed long and earnestly down into the pit. Suddenly he gave a cry. "There's a light ahead of us!" he exclaimed. Pep and Miggs each took a turn at the instrument. Sure enough, miles ahead of them at the bottom of the pit, there appeared a faint greenish phosphorescent light. And now, as they advanced, the light became stronger and stronger, and an hour later the car emerged from the pit into an enormous cavern, lit up with a sort of diffused phosphorescent light. Dr. Hackensaw, with a dexterous turn of the rudder, brought the car around so as to coast along the nearest wall of the cavern. "Pep," said the doctor impressively, "I was right. The earth is evidently hollow at the center, and here we are in the hollow center. But see, even here there are animals and plants of some kind, though like nothing with which we are familiar. Everything seems phosphorescent. See those strange shapes fastened to the rock resembling plants, yet some of them like animals. See those others sprawling and crawling and emitting electrical flashes from time to time? And see those curious creatures flying in the air over there, some with 6 feet, some with no feet at all, some with wings and others with fins or bladder-like balloons to propel them by ejecting air backwards. Truly, we see before us one of the most marvelous sights ever witnessed by man." End of section 42. Section 43 of Dr. Hackensaw's Secrets. Dr. Hackensaw's Secrets by Clement Fezandié. A Journey to the Center of the Earth, Part 4. "Well, Pep," cried Dr. Hackensaw, "you see I was right. Here we are at the center of the earth, and we find there is nothing here but an immense hollow filled with air. My experiments in sending directed radio currents from the surface of the earth, at different points through the center to the antipodes, has led me to this belief, but it seemed so wild that I could not accept it at first. It seems utterly at variance with all that science has taught us. Calculations show that the average density of the earth must be about 5 1/2 times that of water, and as it is less than this at the surface, we know that it must be greater than this down below. Then, too, the earth acts like a rigid body. No, I can scarcely believe my own senses." Pep was not listening. She was gazing earnestly at this wonderful new world that was spread before them. "Please switch off the light," she said. "I want to see what this looks like in the dark." Dr. Hackensaw obediently turned off the searchlight, and the new underground world was revealed in all the beauty of its own phosphorescence. It was an extraordinary sight. Every animal or plant of this grotesque world of creatures seemed to shine by its own light, like a gigantic firefly or glowworm. And yet, colors of the phosphorescence varied in each species, every color of the spectrum being represented, from red through green and yellow to blue and violet. And the forms were marvelous, altogether different from anything our friends had ever seen before. Plants and animals there were of many varieties, and, strange to say, some of the stationary forms appeared to be animals, while some of the movable ones appeared to be plants, capable of flying around in the air from spot to spot, but with seemingly no mouth, eyes, or other definite organs except their wings. Animals, too, there were that could walk around from spot to spot, evidently by means of suction pumps on their feet, similar to those that enable flies to walk along a ceiling without falling. Had it not been for these specialized feet, life would have been very difficult for these subterranean creatures, as the muscular exertion of their movements, here where bodies had no weight, would have shot them up into the air, there to perish miserably from hunger and thirst. Other creatures there were, but these were provided with wings. A few were quadrupeds, but most of them had 6 feet. Some were beautiful to look at, others grotesque and uncouth. There was one flying creature with 2 long trunks, resembling an elephant's trunk where its eyes should have been, and an eye at the point which its mouth should have occupied. It seemed to have 6 mouths, one at the extremity of each foot. The snake-like wrigglers through the air have already been mentioned. These did not seem to be provided with wings of any kind, but appeared to glide through the air much as a snake glides through the water. "Pop," cried Pep, "can't we land here? I'd like to see these creatures from nearby." Dr. Hackensaw hesitated, for in the distance he had caught sight of some huge, unearthly-looking monsters, half hidden in the peculiar vegetation. However, he was as anxious as Pep was to get a nearer view of the flora and fauna of this strange land, and so he assented, and with a turn of the rudder brought the car right up to the rocks. Here a peculiar problem presented itself. How was he to moor the car to the rocks? As objects now possessed no weight, the slightest wind might blow the car away beyond reach. "It is something of a problem," remarked the doctor, "but only a secondary one. I can fasten the car to some of this vegetable growth, though I haven't much faith in the strength of those stems. I could, at a pinch, fasten the car to one of these moving animals. The only drawback would be that the frightened beast would be likely to plunge into the jungle, dragging us after him. A third solution seems to me much more feasible. But before I do anything at all, I must ascertain whether this air is fit for us to breathe." "It must be," replied Pep, "because both animals and plants live here, and animals cannot live without air." "Nor plants either," replied the doctor, "at least not our terrestrial ones. All animals and plants require some source of energy, and obtain that energy from the chemical union of oxygen with some element. Hence they require air. Warm-blooded animals require more oxygen than cold-blooded ones. I have myself kept a sleeping snake under water for 24 hours. As a snake cannot breathe underwater, he could not obtain any fresh oxygen during that time, and hence his consumption of the element, while asleep, must have been very slight. Plants require still less oxygen, but a delicate thermometer will show an increase of temperature during certain periods of flowering, showing that the vital processes, even in plants, require oxygen. But plants with green leaves manufacture much more oxygen than they consume. Parasitic plants that live on the juices of other plants, and saprophytes, as the botanists call the mushrooms and other plants that live on organic matter formed by other plants and animals, do not manufacture their own oxygen. Some of the bacteria, as a matter of fact, are anaerobic. That is to say, they cannot live in air. "Well," cried Pep triumphantly, "that means that I am right, and that the air here must contain oxygen." "Not necessarily. Conditions here may be, and certainly are, entirely different from those on the surface of the earth. All our terrestrial animals and plants owe their oxygen to the direct action of the sun. It is only in the sunlight that the chlorophyll, or green coloring matter of the leaves, can split up the carbon dioxide of the air into carbon and oxygen, and so furnish the energy necessary for animal and plant life. Animals and plants obtain their energy by the recombination of this carbon and oxygen into carbon dioxide again. It is the sun's heat that furnishes the energy used by plants and animals. Even man, with all his boasted inventions, has not yet succeeded in producing food, except by means of the direct heat of the sun. If the sun's rays were suddenly cut off from the earth, we should starve and suffocate as soon as the existing supply of food and oxygen was consumed. Energy exists in coal and other mineral products. the storage products of past ages of the sun's heat. But man has not yet found the key that would enable him to fully utilize these treasures. We shall certainly find it someday. Chemistry is making rapid strides every year, but so far we have not met with success. Nature, however, may have forestalled us. There is no reason why she should not have evolved animals and plants that do not require oxygen in any form. They would, of course, require energy, but energy may be obtained from chemical combinations into which no oxygen enters. In fact, I am inclined to believe that these animals and plants that we see are dependent for their energy upon some sort of electrical action, due, of course, to chemical action of some sort in their bodies. I imagine these creatures are really nothing but a kind of dry cell. Their phosphorescence is different from that with which we are familiar in glowworms and fireflies. This looks more like the discharge witnessed in a Geissler tube, and you will notice occasional sparks and hear crackling noises. Evidently many, if not all, of these animals are highly electrified. Probably, like the electric eel, they possess the power of producing this electricity at will. But, however that may be, my first step must be to admit a little of the outside air into the car and test it thoroughly. No sooner said than done. The air was admitted, and on test was found to be sufficiently oxygenized to render a landing possible without the use of the clumsy diving suits. How the air became oxygenized with no sunlight to furnish energy, and no green plants to split up the carbon dioxide, the doctor was unable to determine. All he saw was that the air was respirable, so he proceeded to make the car fast to the rocks. This was accomplished in the following curious but ingenious manner. The doctor had brought along with him several pairs of suction boots designed to enable the wearer to walk up and down the perpendicular walls of the pit. These boots have already been described. A steel framework or basket was worn by the climber under his clothing. This framework was rigidly attached to the boots and supported the wearer comfortably, enabling him without fatigue to walk up a perfectly vertical wall, his own body being horizontal. It was Dr. Hackensaw's plan to use a pair of these suction boots as anchors for the car. This was accomplished in a trice, and when the air was exhausted from the boots, the car was moored to them and thus held securely. Meanwhile, our friends had each donned a pair of the suction boots, after removing the body framework, which was, of course, unnecessary in the present case. Then they cautiously landed on the rocks and prepared to explore this wonderful new land that they had discovered. Fresh marvels greeted them on every side. Here was one peculiar creature that looked very much like an erect fan on 3 legs. Another one had what looked like a dog's head, with 3 prehensile tails dangling behind. The creature used these for climbing over the peculiar tree-like stationary animals, curling their tails around the boughs or limbs. The nose of the creature was like an open funnel. It would be impossible even to attempt to describe the strange plants and creatures presented to view. Most of them were decidedly grotesque, but some were exceedingly beautiful, among others a wonderful flying creature that looked like a large soap bubble with a beautiful iridescence that flashed all the colors of the rainbow. 3 gauze-like wings, the 3rd vertical on top of the body, enabled the creature to fly with ease. Huge monsters there were, too, large, ungainly reptiles that fortunately kept at a distance. These all seemed to have 6 feet, and some of them strangely suggested terrestrial insects in their general aspect. One of these creatures, with a long pointed bill, armed with sharp teeth, looked angrily at our adventurers and uttered a sound halfway between a bellow and a roar. For an instant it looked as if he were going to attack them, but then he thought better of it and turned around and moved slowly away. Meanwhile, Miggs had caught hold of one of the immovable animals that were rooted to the ground, and he got a violent electric shock for his pains. "Gee," said he, as he rubbed his shoulder, "that's some voltage there, you bet. I'd like to use this animal plant to run my wireless set. No fear of not having enough juice." Dr. Hackensaw was specifically interested in noticing the various means by which the different species of animals and plants counteracted the lack of gravitation. Objects having no weight, the slightest movement of an animal was liable to shoot it off into the air, where it must perish miserably from hunger and thirst, unless enabled in some way to get back to land again. Nature had provided some with wings, others with suction feet resembling those of flies, others still were rooted to the ground like plants, while still others were provided with a slimy substance like bird lime that glued them to the ground and yet allowed them to move about at will. But some of the creatures appeared to have no means at all of adhering to the rocks. These lived in burrows and seemed to depend entirely on the friction of their bodies in the burrow to keep them from flying off. This seemed evident from the fact that some of their dead bodies were floating around in the air, while others were evidently dying, having through some accident loosed their hold of the earth and been carried up into the air and being unable to get back again. Pep took pity on these poor creatures. "I'm going to catch them and put them back on the rock again," she cried. And, suiting the action to the word, she suddenly let the air into the vacuum chamber of her section boots, at the same time springing upward with all her might. Her experience in the car ought to have taught her better. There being no attraction of gravitation here, the result could have been readily foreseen. The impetus of Pep's leap sent her flying high up in the air, turning a series of rapid somersaults as she went spinning. Up, higher and higher she went, for she had got a good start, and Miggs and the doctor gazed at her in open-mouthed astonishment as she ascended. "Gee," cried Miggs, "she'll be dizzy all right. That beats anything that happened in the car. I bet she'll go a mile before she stops." She didn't go a mile, but she went up quite a distance before the resistance of the air finally brought her to a complete stop. There, faint from dizziness, she remained motionless a few moments, and then started swimming slowly down through the air. But several of the beasts had noticed her flight, and one monster, more venturesome than the others, decided that she might be good to eat. This was a ferocious-looking creature with crocodile-like jaws, a horn on the middle of his forehead, a pair of bony wings, and a crested back. Poor Pep's heart sunk as she saw the monster fly toward her. Dr. Hackensaw and Miggs gazed helplessly at the sight, and then the doctor, suddenly remembering that he had some atomic energy pistols in the car, clambered up the ladder and emerged a few moments later carrying a pistol in each hand. These were peculiar-looking weapons. They hurled a bullet not much larger than a BB shot, but the bullets were so constructed that, on striking an object, there ensued a release of atomic force which exploded the missile with undreamt-of violence. Dr. Hackensaw was too late, however. The monster was already so close to the girl that the doctor dared not fire. And now a fresh actor appeared upon the scene. Among the grotesque creatures in this strange land was one who bore a head that somewhat suggested the head of a man. Instead of arms, the man had 4 tentacles like those of an octopus. He had no wings, but he had 2 peculiar tails that curled up in a comical fashion. This creature appeared to possess intelligence. He too had watched Pep's flight through the air, and his eyes followed her greedily. But it was evident he wanted her for a mate, not for a dinner. When he saw the winged crocodile start, his own mind was made up in an instant. He jumped on the back of a creature that slightly resembled a dragonfly, and using 2 of his tentacles to drive the creature, he started off in hot pursuit. Though he had no wings of his own, he had intelligence enough to use the wings of other creatures. As usual, mind triumphed over matter. The light dragonfly, even though encumbered with a rider, was far swifter than the heavier reptile, and reached the crocodile just as the latter had opened his enormous jaws to swallow down poor Pep. The rider had no weapons, but he seized the reptile with 2 of his tentacles and switched on his electric current. The shock must have been something frightful, for the monster gave a wild jump and then remained motionless, absolutely paralyzed. The man, if so we may call the rider, grabbed Pep with his 2 free tentacles, and then started his steed for land. Vainly Pep tried to disengage herself from this new monster's grasp. She had escaped one danger only to meet another worse one. Dr. Hackensaw looked vainly on, but dared not fire. Meanwhile, the crocodile had slowly recovered from the stunning blow it had received, and perceiving that its enemy had not yet landed, it started in pursuit. Possibly it knew that the foe, having discharged its thunder, was powerless for a while. At any rate, on came the reptile, and, travelling faster than the dragonfly with its double burden, reached the ladder just as the man was about to land, and seizing him by the hindquarters, crushed them in its powerful jaws. But now Dr. Hackensaw saw his chance. He raised his pistol and shot straight for the crocodile's tail. A tremendous explosion was heard, and the rear end of the crocodile's body was hurled skyward in infinitesimal fragments. The doctor then seized Pep, who, frightened but unhurt, had extricated herself from the loosened tentacles of the wounded man, and, unwilling to remain longer in this dangerous region, he regained the car. The rest of the journey is soon told. Dr. Hackensaw resolved to push on at once to the very center of the earth, and carried this resolution into effect. But he found nothing of special interest. It was merely one enormous sea of air, with islands of various sizes floating in it. These islands were particles of the solid rock, which had become broken off and hurled upward. Most were barren, but some of them contained animal and plant life. The largest of these islands was about 2 miles in diameter. Here the party landed, and Pep was surprised to find that even on this large island the attraction of gravitation was inappreciable. But Dr. Hackensaw explained the matter as follows. Newton's law, said he, is that the attraction varies as the mass of the attracting body, and inversely as the square of the distance from the center of attraction. Our Earth has a radius of 4,000 miles. This island has a radius of 1 mile. The masses are as the cubes of the radii. Hence the mass of the Earth exerts a pull 64 billion times that of the island. But this figure of 64 billion is partially offset by the fact that here we are only 1 mile from the center of attraction, while on the Earth we are 4,000 miles away. Hence the pull due to nearness is 16 million times as great here. Taking both these factors into consideration, the attraction on this island is only 1/4,000th of what it is on the Earth. Miggs, who weighs, I believe, 100 pounds, would weigh here only 1/40th of a pound, say 1/3 of an ounce. Now, if Miggs were on the Earth's surface and weighed only 1/3 of an ounce, he would shoot up into the air, not like a balloon, but like a skyrocket. His buoyancy would be greater than that of a cork in water, and by no possible exertions of his own could he swim down to Earth again. Here, however, it is somewhat different. The buoyancy of our air at the Earth's surface is due to its weight. Here the air has no weight, or a weight so small that it is inappreciable. Hence the island does pull us to it, though we scarcely feel the pull, as it is so light. When the party reached the entrance of the pit on the homeward journey, they found several of the ungainly monsters prepared to dispute their passage. A few bullets from the atomic energy pistol, however, soon put the creatures to flight, and the ascent of the car began. This was much slower than the descent, for stops had to be made occasionally, and the car fastened to the walls of the well, while radio messages were sent up to ask that more air be allowed to enter the shaft. But all things have an end, and one fine day our party finally emerged from the pit, and found that a splendid reception was awaiting them at the South Pole, and they well deserved it. It was no mean achievement they had accomplished, the exploration of the center of the Earth. As for Miggs, he drew a long breath and remarked to Pep, "Gee, I suppose Dr. Hackensaw will be wanting to civilize those guys down there at the center of the Earth. But I never want to see them again. Me for the sunlight and a place where you can jump up without going a mile, and spinning around like a cartwheel as you go up." End of section 43.